Hey everyone, have you ever just looked around your room, maybe out the window, or literally just stared at your own hands and thought, what is all this stuff actually made of? Well, today we are going to dive right in and uncover the actual science of the physical world. We're going to break down the literal building blocks of the universe.
And to help us figure all this out, I want you to meet our friendly dragon guide, Amber. Just look at her. Soft features, those little wings, and those big expressive eyes. Amber absolutely loves science. She's going to help us see the world in a totally new way and show us that science isn't just, boring numbers in a textbook. It's the real, actual magic of how everything around us works.
So here's our roadmap for today's explainer. First, what is matter? Second, matter versus non-matter. Third, solids, liquids, and gases. Fourth, measuring mass. Fifth, measuring volume. And finally, number 6, scientific investigations.
Okay, let's jump right into part 1. What exactly is matter?
Matter is officially defined as anything that has mass and takes up space. And honestly, that's it. That is the golden rule of the whole physical universe. Basically, everything you can hold, push, or, say, keep in a jar is matter. It really doesn't matter if it's a tiny, rough pebble you just picked up on the playground or a giant, heavy dragon like Amber's parents. If it has mass, meaning it's made of actual stuff, and it takes up physical room in the universe, it is matter. You are matter. The screen you're looking at is matter. Even the snacks you ate earlier? Yep, totally matter.
Moving right along to part 2. Matter versus non-matter.
Let's do a little comparison here. On the matter side, we've got tangible things we can hold and interact with. Think of a crisp apple, our dragon friend Amber, or a glass of water. They all take up physical space, right? But now consider the non-matter side. We're talking about things like light, sound, and shadows. Think about the sunlight streaming through your window. Sure, it warms your face, but it doesn't take up physical space in a jar. You literally can't weigh it on a scale. And what about the sound of Amber's joyful voice? It travels to your ears, but it has zero mass. These are forms of energy or optical effects. They are definitely not matter.
Have you ever actually tried to catch a shadow? Seriously, think about it. You can jump on it, you can wave your hands over it, but you can never actually grab it, can you? And that's because a shadow isn't a thing. It's simply an area where light is being blocked by an object, like maybe it's being blocked by you. It takes up absolutely zero physical space and has zero mass. So a shadow is pretty much the perfect example of non-matter. All right, let's head to part 3, solids, liquids, and gases.
First up, we have solids. Solids hold their own shape. Think of a hard rock or a block of wood. If you put a rock on a table, it just stays rock-shaped. Simple enough, right? Second, we have liquids. Liquids actually flow to fit their container. Imagine pouring a bubbling liquid potion into a round flask. That liquid completely changes its shape to perfectly fit the bottom of that specific flask. And third, we have gases. Gases spread out to fill all the available space. The air we breathe is a gas. You can't see it, obviously, but it's swirling around invisibly, literally filling the entire room you're sitting in right now.
Okay, part 4, measuring mass with balances.
In science, we generally measure mass in grams, which we write as a little g, and kilograms, which we write as kg. So what does a gram actually feel like? Well, imagine holding a single small metal paperclip right in the palm of your hand. You know, that tiny feather-light feeling? That is about 1 gram. Now, imagine holding a giant, heavy, super thick spell book or a massive dictionary. That heavy object that totally makes your arms tired, that is measured in kilograms. To put that into perspective, 1 kilogram is actually equal to 1,000 grams.
Next up, part 5, measuring volume with cylinders.
So here's a puzzle. How do we measure the volume of something weirdly shaped, like a rough, bumpy rock? Well, we use something called the displacement method. It's kind of like a magic trick. Step 1, you pour some water into a measuring glass called a graduated cylinder. Step 2, get right down to eye level and read the starting milliliter line. Step 3, carefully drop your rock into the water. And step 4, check the water level now. Because the rock takes up space, it actually pushes the water up. If you subtract the starting water level from the new water level, that difference is the exact volume of your rock. Boom! You just measured space.
And finally, part 6, a plasticine scientific investigation.
Now I've got a really thought-provoking question for you. Imagine we take a round, heavy ball of plasticine clay, and we put it on our balance to measure its mass. Okay, we write that number down.
Then, we take that exact same ball of clay and we squish it as hard as we can until it's a perfectly flat pancake. We haven't added any clay and we haven't taken any away, but it obviously looks totally different. Here's the big question. If we put that clay pancake back on the balance, does its mass change?
The answer is no. The mass stays exactly the same no matter the shape. This is a really surprising but absolutely fundamental scientific truth called the conservation of mass. Actually, think of it this way. Just because you change what an object looks like by stretching it, squishing it, or bending it, you aren't actually changing the amount of matter inside it. The mass is exactly the same because the exact same amount of stuff is still there. It's just rearranged.
We have covered so much ground today, from uncatchable shadows to solid rocks and squishy clay. So, I want to leave you with one final thought. What magical matter will you discover in your own room today? Look closely at the things around you. Weigh them in your hands. Really think about the space they take up. The universe is absolutely full of fascinating matter just waiting for you to explore it. Keep observing, keep questioning, and keep learning.